Okay, in this video, we're going to be having a brief introduction to the unit circle, why it's important, and how it relates to the trigonometric functions. Okay, before we get to the exercises, let's talk about this guy first. So what does a unit circle even mean? Unit, because you're hearing unit length, just means factor of 1. So it means that the radius of a unit circle is 1. And why is this important? Because if we draw in these triangles with some given angle, let's say 30 degrees, then with just this information, we know the height and the length as just pure trigonometric functions. Okay, so let's say we want to find the height of this point right here. Let's set up the trig ratios we know and love from geometry. Okay, so we have the opposite and we know the hypotenuse. The opposite in hypotenuse is sine. So that means that sine of 30 degrees must be equal to, since this is a y coordinate, let's just call it y, over 1, or in other words, sine of 30 is equal to y. Okay, perfect. So sine of 30 is half of the puzzle for where that coordinate is. And to evaluate sine of 30, this is why I recommend knowing your trig values. Sine of 30 is also equal to 1/2. Okay, so this is 0.5 up, about halfway to where this is, which is 0, 1. Okay, and let's do the same logic for this distance here horizontally. We can set up the same ratio. We know the hypotenuse is just 1, and we want to find this adjacent. So adjacent hypotenuse has to be cosine of 30 is equal to x over 1. Well, x divided by 1 is just x. So we have that cosine of 30 degrees is equal to x. And you may know that cosine of 30 is equal to root 3 over 2. If you're struggling to memorize this, I will post a video later soon on how to memorize these pretty easily. Okay, so in other words, the coordinates of this point, the terminal point, is going to be root 3 over 2 first, and then 1/2. And because the hypotenuse, being the radius here, is always 1, the coordinates of this point right here, terminal point, are always going to be cosine of theta as the x, and sine of theta as the y. And if you do change from a unit circle to a different circle, you just scale these accordingly. Okay, so let's see how we can apply it to these problems here. T is the length of an arc on the unit circle starting from 1, 0. Okay, so 1, 0, where is that? Okay, it'd be here. State the quadrant in which the terminal point of the arc lies. Find the coordinates of the terminal point xy on the unit circle. Give exact values for x and y if possible. Otherwise, approximate to 3 significant figures. Okay, so the part of this length is just telling us the angle, basically. And here for pi over 6, this is a radian. So we have to convert this radian into degrees. Okay, a quick review on how to do that. If we have a measurement like pi over 6, we have to know how many radians are in a circle and how many degrees are in a circle. So in a circle, there are 360 degrees, while there are 2 pi radians. Okay, dividing both by 2, just a little bit over here to show they're linked. This means that for every pi radian, we have 180 degrees. Okay, and here if we have pi over 6 radians, logically that's going to mean that we have a 30-degree angle we're working with. Okay, so using that knowledge now, it's asking us to find the coordinates of that point with an angle of 30 degrees, and we did just that as an example. So for that A here, the answer is going to be root 3 over 2, comma 1 half. Let's see what to do with 3 pi over 2. Okay, and notice here that the angle 30 is counterclockwise from the circle. So for these weird angles, we're just going to do that same rotation, even if it looks strange. Okay, so let's draw that. Okay, so obviously if we just went here, it's going to be 90. So we have to keep turning 90, 180, until finally we get here. This 270-degree rotation. How do I know that? Because 30 pi over 2, that's going to be pi plus pi over 2, so 180 plus 90 degrees. Okay, so we're asked to find here where this point would end up. Okay, but notice here that when we rotated this point along the circle, a perfect 270 degrees, these are easy coordinates. You can just look at this and immediately tell right away, since it has a radius of 1, that's going to be 0, comma, negative 1. Since this spans 1 and is in the down direction, that's going to be 0, comma, negative 1. And 0 because we're still on the y-axis here. If it had been pi over 2, which is 90 degrees, this point would just go over here, which is an easy 0, comma 1. Okay, so for this one, it's going to be 0, comma 1. Okay. And here we're going to state the exact value, if possible, of the sine, cosine, and tangent of each real number. Okay, so for pi over 3, that's going to be, if pi is 180 degrees, that's going to be 180 divided by 3, which is 60 degrees. Okay, so now we're asked to find what sine of 60 degrees, then cosine of 60 degrees, and then tangent of 60 degrees. The reason I'm writing them out as degrees is because I recognize them from the 30, 60, 90 triangle, which makes it easy for me to remember. And if you don't remember that special right triangle, I'm going to draw it out here for you. It's just a rough sketch. Okay, this is going to be 1. This is going to be root 3. This is going to be 2. 30, 60, 90. Okay, so for sine of 60, we have to take the opposite over the hypotenuse. We have opposite is root 3, and the hypotenuse is 2. So that means sine of 60 is root 3 over 2. Cosine of 60, look at that. That's going to be the adjacent divided by hypotenuse. So that's going to be 1 half. And now for the tangent. The tangent is the opposite of the adjacent. So that's going to be root 3 over 1, which is just root 3. Alternatively, when you only know the sine and the cosine, you can find the tangent quite easily. Let's see how that works. So if sine is equal to the opposite over the hypotenuse, and the cosine is the adjacent over hypotenuse, and we want opposite over adjacent, we can manipulate these two values to get this one. Let's do that by just dividing. So over h divided by this, it's going to be h over a is equal to these cancel over a. So that means that sine of theta divided by cosine of theta is equal to tangent of theta. So for when you have messy trig values, you only have the sine and the cosine, you can just divide them straight across to get tangent. Okay, so let's try this next one here. I over 2, find a sine, cosine, and a tangent. Okay, so drawing this one is a little strange, so let's go back to the unit circle and see if that can help us. Okay, remember that we can represent degrees and radians here on the unit circle by following this dot. Okay, and as I mentioned before, if we just turn 90 degrees here to get pi over 2, here the height is going to represent the sine, as we found earlier, and the x here is going to be the cosine. So that also means that since the angle formed here is a 90-degree angle, cosine of 90 has to be 0 since our x there is 0, and sine there has to be equal to 1. Okay, what about the tangent? We can't easily get tangent from here, can we? Well, let's recall the rule we found earlier, that tangent is equal to sine over cosine. Okay, and if we know that is sine over cosine, let's try it. 1 over 0 is tangent of 90. Okay, so surely that means that our tangent of 90 is equal to 0, right? No, remember, this is division by 0. We can't do this. So really, tangent of 90 degrees is undefined. Okay, so for this one, we can write sine, cosine, tangent. Sine we found to be 0. Cosine we found to be 0. And tangent finally, that was undefined. Okay, now for 3 pi here. Let's apply the same logic. There are 2 pi radians in this circle, and once we go past that, we're just repeating. So that means that 2 pi, 4 pi, 6 pi, 8 pi, they would all look like the same thing since you've crossed the circle that many times. So, for example, 2 pi, it's just like you did nothing. And if you go another 2 pi, it's like you did nothing, which is 4 pi. Go another 2 pi, it's like you did nothing. Another 6 pi, 8 pi, they all have no effect. That is called a period. How often it takes to repeat a value. So, using that logic, the sine of 3 pi is going to be equal to just the sine of pi. And the same logic goes for the cosine. Our point is going to be in the same location, since that extra loop around the circle is irrelevant. Okay, so this is a little easier. We would go these 180 degrees or pi radians, and we would end up here. Okay, let's observe the x and the y. The cosine here is going to be -1, since the x is at -1. And the sine is going to be 0. Okay, so that means that sine of pi, since it was just at 0 over there at the bottom, sine of pi is 0, and cosine pi equals -1. Okay, and for tangent, let's just divide these two. We're going to get that tangent of pi is equal to 0. Okay. And that about wraps up our introduction to the unit circle. I hope you enjoyed this video, and if you want more videos like these, let me know in the comments below. Thank you.